Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, functions in mathematics, what we are going to discuss today is inverse of a function. So let's begin. After completing the very lesson today, my dear student will be able to explain the relationship between a function and its inverse. And also, you also be able to find the inverse of a given function. These are what I hope you'll be able to do after completing the very lesson today. As usual, my dear student, in your favorite segment of the lesson, Maths is fun. Today, I'll give you another interesting number, and this number is 50. 50 is so unique, so special. I'll tell you what is interesting with this number 50 after completing my lesson today, so don't go away. To begin the lesson, my dear student, let us consider this typical function f, which assign each and every x in x a single element in the set y. If this is a function, then assume there is another function which are assigned to each and every y in y. That is, y is in the second set of this f. That is the codomain of f. So if there is another function which picks each and every element in the codomain of f and assign it to a single element in the domain of f, that is the reverse, then that function is called the inverse of f, and is usually denoted by this symbol f with the subscript of -1, and this is now called f inverse. Thus, if you have that function, what it does, it now assign each and every element from this y to a single element in this set x. You can see f is x to y, but the f inverse will now be y to x. Let's just see this relationship in diagram. That is, this diagram below shows the relationships between f and its inverse. If I take this typical example, you have set x containing a, b, c as elements. That is the domain of the function f. And look at the assignation from x into y. Then if there is another function that we call the inverse of this very function, which would now be this drawing. Look at the reverse assignation. Now, it is a to 2. Now it will now be 2 back to a. Look at the assignation. Look at the arrowhead pointing. It is now this element 2 that is assigned to this single element a in the inverse. But in the f, it is now a assigned to this 2. Similarly, if you check the other assignation, they are exactly the reverse of this f. So this is the inverse of the function. So it reverses the assignation of the original function f. For a function to have an inverse, that function must be one-to-one and onto function at the same time. You can see exactly, because if the inverse would now be considered to be a function, all the elements in its domain, the domain must be assigned to a single element. You can see if this original function f were not onto function, if it is not onto function, which means there will be some elements in the codomain. We don't have pre-images. And you can see if we are to get the inverse, that is the reverse assignation, there will be some elements that will not be assigned, which disqualify it to be a function. So for this f to have a function, or for every function to have inverse, it must be both one-to-one and onto. So next, let us learn the rule. It is this rule that will guide us what we need to do to find the inverse of a given function successively. So it says to find the inverse of the function f of x, for example, what we needed to do. Number one, it says replace that f of x with y. So in the given formula for the given function, that is f of x equals to whatever. So that f of x by the left hand side, we now replace it by this variable or by this letter y. This is step number one. Step number two says interchange the x and the y variables. So after replacing f of x by this letter y in the very first step, so what you now do in the next step, where you have x, you put y there, and where you have y, you put x there. That is the interchanging of x and y variables. Next you do, that is step number three. Step number 3 says you now solve for y, and at the last step you now replace the y by f inverse of x. These are just the 4 steps that you have to take in order to find the inverse of a given function successfully. We are going to make use of these stages in practical in our examples. Let's just do. So example number 1, it says if f of x equals to x plus 5 all over 3. The question asked here is to find the inverse of this very function. Solution to this very problem. So you remember the steps given. Let me just copy the function. First, that is the given function f of x equals to x plus 5 all over 3. So the very first thing that we do in attempt to find the inverse of this function f, it says we now replace this f of x by letter y. So I'm now going to remove this f of x and put y instead, then I'll copy the right hand side. Let me do that. So I have substituted f of x by y. Look at it. Then the next step says interchange y by x and x by y. So where I have y, I put x there, and where I have x, I put y there. Look at it. So next step says we will now solve for y, meaning make this y subject. So in attempt to do that, I will now cross multiply. So I'm going to have y plus 5 times 1. This gives me y plus 5, and x times this 3 gives me 3x. And then I will to get this y alone by the left hand side, which means I will take this positive 5 to the right hand side. That gives me y equals to 3x minus 5. So I have now solved for y. So the last step says this letter y now replace it by f inverse of x. So let me do that. So I now have instead y, I'll now put there f inverse of x, then I'll copy my right hand side. So this is the inverse of this very function. Let us move and take another example. Example number 2, it says if f of x equals to 9x plus 2, and the g of x equals to x minus 2 all over 9. And let this be functions. The question asked here is to prove that f and g, that is these two functions f and g, are inverse of each other. So let's find out. Solution to this very problem. So to prove this, that is f and g, that is f is the inverse of g and g is the inverse of f. What we need to do is to find the inverse of each of this and compare with the given function. That is to find f inverse of x and see whether it's exactly the same as g of x. And to find the inverse of this g of x and see whether it is exactly the same as the function f of x. So let me start. So starting with the function f of x, copy it. Remember, it says replace the f of x by letter y. Let me do that. So I replace f of x by y. I now have y equals to that x plus 2. Next step says where you have y, put x there, and where you have x, put y there. Let me do that. So I'm going to have x equals to 9y plus 2. The next step says I should make this y subject of the formula. So in attempt to do that, I will now shifted this to 2 to the left hand side. Look at this 2 shifted to the left hand side. I have x minus 2 equals to 9y. Then I'll divide both sides by 9 to get y alone. So there I'm going to have y equals to x minus 2 all over 9. Next is now is replace this y by f inverse of x. So I'm going to have f inverse of x equals to x minus 2 all over 9. So this is the inverse of this very function. And if I look at it, look at the given function g of x, I can see it is the right hand side is exactly the same. Let me find this g of x. It is inverse. So g of x equals to x minus 2 all over 9. I just copied the given function. Then I will now find it is inverse. Step number 1, replace g of x by letter y. Let me do that. So I have y equals to x minus 2 all over 9. Next step says you put 2x where you have y and put y where you have x. So let me do that. So I'm going to have x equals to y minus 2 all over 9. Step next is says I should make this y subject. So I will now cross multiply. That gives me y minus 2 equals to x times 9x. So I'll now take this to minus 2 to the right hand side. I'm going to have y equals to 9x plus 2. Then I will now replace this letter y by g inverse of x. This, remember, is g of x. So I'll now write g inverse of x instead y equals to 9x plus 2. So this is the inverse of the function g, and this is the inverse of the function f. And if I compare this g inverse with the function f, I can see the right hand side is exactly 9x plus 2, 9x plus 2. So which means this is proved that is f and g are inverse of each other. Example number 3 says if f of x equals to open bracket, inside the bracket is x raised to 3 minus 8, and the bracket raised to the power of 5. The question asked is to find f inverse of 0. F inverse of 0. That is the image of this element 0 under the function f inverse. So which means I have to get to the formula for this f inverse before I now substitute my 0 in the formula. So let me do that. So solution to that, copying the given function f of x. So remember this step, it says first replace f of x by letter y. Let me do that. I have y equals to open bracket x raised to 3 minus 8 raised to the power of 5. I'll now interchange x and y, meaning where I have y, I put x, where I have x, I put y there. So I'm going to have x equals to open bracket y raised to 3 minus 8 raised to the power of 5. So next thing, I attempted to get this y subject of the formula. What I will need to do is to clear this power 5. How I'll clear it, I will now raise each and every side to the power of 1 over 5, so that after multiplying 5 by 1 over 5, I'll have power 1 here. So let me do that. So I'm going to have x raised to the power of 1 over 5, that is my left hand side, equals to my right hand side after raising it to the power of 1 over 5. 5 times 1 over 5, we will now have 1. So this will now be y raised to 3 minus 8. So I'll continue. I will now shift this minus 8 to the right hand side. It becomes plus. So I'm going to have x raised to 1 over 5 plus 8 equals to y raised to 3. Then I will now take cube root of both sides to get y alone. So I will now have y equals to cube root of x raised to 1 over 5 plus 8. So I'll now replace this y by f inverse of x. So there I now have the inverse. That is the formula for the inverse function to be equals to cube root of x raised to 1 over 5 plus 8. It is in this very formula that now I'm going to substitute this 0 to find the image of this element 0 under the given function f inverse. So let me do that. So I'll now find f of 0. F inverse of 0, I beg your pardon. So this will now be equals to cube root of 0 raised to the power of 1 over 5. I have replaced this x by 0, then plus 8. 0 raised to n3 is 0. So that gives me simply cube root of 0 plus 8, which will now be the cube root of 8, and the cube root of 8 will now be equals to 2. So this is the F inverse of 0. With this, I have come to the end of this very lesson, my dear student. I hope you find it resourceful. Thank you for your attention. Let me just move to the last segment, Mrs. Fan, and explain what is interesting with the number 50. 50 is the smallest number that can be expressed as a sum of the two squares in two different distinct ways. That means 50 can be expressed as sum of two squares, and those the sum of two squares in two different distinct ways. Let's justify that and see. 50 can be expressed as 5 raised to 2 plus another 5 raised to 2. You can see these are two square numbers. 5. Find what is 5 square, it give me 25. 5 square give me 25, and if I add 25 and 25, I will get my 50 back. 50 also can be expressed another square numbers, 1 square and the 7 square. 1 square is 1, 7 square is 49. If I add 1 and 49, it will give me my 50 back. So 50 is the smallest number that can be expressed as sum of two square numbers in two distinct ways. Thank you for your attention. We see more of these things in mathematics in our subsequent lessons.